Let's shut down interface 001 from PE1. Let's do that. Interface giga 001 on PE1, then shut down. Then on PE2, display etrunk 12. We have the etrunk master on the PE2 device. After we disabled interface 001 from PE1 side, now PE2 is the master in the etrunk. It will support CE4 to get to CE2 through PE3. And from PE3 side, we have two VCs. One VC from PE3 to PE1. This is the master VC, and another VC from PE3 to PE2. This is the backup VC. Let's check on the PE3 side. Display MPLS L2VC 1, which is for PE1, and this VC status is up and AC status is up. The attachment circuit, which is the service interface going to CE2, is up, and also we can find that its status is primary. Let's do the same for VC2. It's also up because it can reach PE2 normally, and the AC status is up as well. Its mode is secondary, so it's not used because this is the secondary VC and the primary VC is PE1. Now, if CE2 wants to send traffic to CE4, it will send its traffic to PE3, then PE3 will use the primary VC, which is PE1. Now, PE1 needs to get to CE4, but its interface 001 is down, so the traffic will be dropped in this case, because PE1 doesn't have any path to CE4. So the result from CE2, if it tried to ping CE4, will be request timed out. There is no reply. Because, as we said, PE3 forwards the traffic to PE1, and PE1 doesn't have any path to CE4. To solve this problem, we will create a pseudo wire or PW between PE1 and PE2. On the access service interface of PE1 going to CE4. Let's do that. From PE1, we will go to the service interface Ethernet trunk 12. This service interface is configured with MPLS L2VC going to PE3, and we will create MPLS L2VC, which will be going to PE2, in this case 2.2.2.2, and with a VC ID will be configured as 12. Then its mode is bypass. Bypass is used when there is no direct access from PE1 to CE4. The interface is down, which is 001, so it will use the bypass VC to PE2. Then PE2 will go to CE4. I'll do the same for PE2. Let's save first, then go to PE2, interface, Ethernet trunk 12, MPLS L2VC, the target PE is PE1 and the VC ID is 12 as well, and its mode is bypass. Save. Now let's check the IP connectivity again. Now I get reply because in this case PE3 forwards the traffic to PE1, then PE1 will forward the traffic in the bypass VC to PE2, then PE2 to CE4. We saved the configuration for PE1. Let's shut down PE1 device and check on PE3. Display MPLS L2VC1. Now the VC status is down because PE1 entirely in the down state, so the VC is down, and in this case the active state is inactive. Let's go to VC2, which is going to PE2. We have here the VC status is up, and also it's used because the VC status of 1, which is the primary, is down now. So let's make sure that the ping is still working. It's still working because in this case PE3 uses the VC circuit to PE2, then PE2 will be going directly to CE4 using interface 003. To summarize what we've done in the lab, we configured primary and secondary PWE3 from PE3 device. We specified the interface going to the service node, and then we configured this service interface with two VCs using MPLS L2VC and the target PE device, then the VC ID. This is the main VC, and the other VC ID going to the secondary device, which is PE2 in our lab, and we configured and added the keyword secondary to the VC. From PE3, the secondary VC will be used only if the first main PE went down. We have to note that the VC ID must be identical between the PE pairs. We must configure bypass PWE3 between PE1 and PE2 in case the access service interface from PE1 going to the service node went down, but PE1 is still up. On PE1 and PE2, we must specify the interface from the service side and to be configured with MPLS L2VC, the peer address of the PE, which is PE2 if we configured on PE1, and the VC ID, then bypass.